with this, what is the vocabulary here? What does rate of change actually mean? A rate of change is a ratio. Well, what's a ratio? We got to know what that means. What's a ratio?
Comparison.
Comparison. One thing compared to another. And we typically write it either as like we can put the first thing that's being compared, we might write it with a colon, and then we have it as the second thing behind that. More typically, it's written as a fraction. The numerator compared to the denominator. Okay, so a rate of change is a ratio that compares the amount of change in a dependent variable, and we know it all about dependent and independent. So we compare the rate of change in a dependent variable to the amount of change in the independent variable. So we're going to have to make some decisions. Which one, again, we've already done this back in chapter 3. We're going to have to make a decision. Which one should we consider to be the dependent variable and which one would be the independent variable? Now notice, this is going to be really important that you keep this in mind. Dependent is going to be upstairs in our rate of change. Independent is going to be downstairs. Now let me give you some examples of why it's important that we decide which one's going to be the dependent and independent again. Because remember, we talked about this before. We talk about if you get a job and you're paid by the hour, do you typically go home and say to your parents, I'm going to work so many hours for so many dollars? Or does it go like this? I'm going to get so many dollars for so many hours. Like, do I get paid by the dollar? Do we talk about it as dollars per hour or hours per dollar? If you get a job and you get paid by the hour, does the employer say to you, I'm going to pay you a third of an hour for $1? Or do they typically say it like this? I'm going to pay you $9 an hour. Yeah, the $9 an hour. So again, that's like, basically they're saying then that the $9 that are upstairs, that's the dependent variable. Per hour, the hours are going to be the independent variable then. So we have to make that decision when we're setting up rate of change. We can't be haphazard about how we set that ratio up. Okay, so in this problem, we're at the bottom of the page. Check it out, problem number 1. The table shows the balance of a bank account on different days of the month. How many of you have a bank account? Anybody here got a bank account? Okay. And there's a balance in it. What's that mean?
Money.
How much money's in there, right? Yeah. So if you went to check on your balance today, you would be checking to see how many dollars and cents are actually in your account at that time. That's what the balance means. So the balance of a bank account on different days of the month. Find the rate of change for each time interval. How much did it go up or how much did it go down by? What's the average it went up and down over a time period? And then we're going to decide during which time interval did the balance decrease at the greatest. Well, notice I was nice and put the table in here. Will you compare and make sure I wrote it correctly from the book? Did I copy the table well? In other words, in day 1, was there actually $550 in the account according to that table? Okay. Let's check it out, make sure we have them all right.
Yeah.
Okay, so what we're going to do first is it says we're going to plot each point and connect the points with line segments to represent the intervals. Well, we can't plot the points, so we decide what's going to be x and what's going to be y. And we got to remember x is the independent variable and y is the dependent variable. So the first decision we have to make, these are dollars right here, and those are days. So do we want it to be days per dollar, or do we want it to be dollars per day? Which one makes more sense? Cameron?
$1 per day.
Dollars per day makes more sense, doesn't it? So that means if we're going to go with this one, remember the y's are upstairs. So in a rate of change, we have the y's upstairs and the x's downstairs. So that means we're going to make the balance is going to be our y value, and the days are going to be our x value. Will you put that in the table, please? Because that's important. We want the dollars to be our Y value, and we want the days to be our X values. So now we're ready to graph some points. Because this is an ordered pair right here. This is ordered pair 1, 550. Okay, but it looks like we have to finish our coordinate plane here. We have to finish numbering it. Okay, so notice how nice I was. I already picked the X value for you. I said days are going to go on the X-axis. What scale am I using on the X-axis for this? This is really important also. It's going by twos. This one is really a 2 here. I just didn't write the 2, did I? Because it's good. The numbers are going to be so close together. So I'm going to skip writing some of the numbers, but that does not mean that that grid line does not represent that number. So the first grid line is 2, the next grid line is 4, the next one would be 6, 8, 10. The next one we're going to mark is going to be 12. So go ahead and finish numbering across the X-axis and be really careful that you're doing it accurately. Mine are going to be hard to read because it's hard to write small on this. But I can tell you that the last grid line should be labeled 40 when you're all done. Okay, and then the next thing we're going to decide is what's the scale I used on the Y-axis for the dollars for the balance. So remember how there's that squiggly line? It's kind of scrunching a part of the number line, saying we don't need this part of the number line. And I'm starting at, instead of starting at 0, I'm starting it at 150. So what's the scale that I'm using on the Y-axis, Brighton? 25. 25s it's going by. 150, 175 would be the next one. I just didn't write the number. The next one is 200. So you can kind of think of it this way. We're going to skip numbering every grid line and just go up by 50s, right? So finish numbering the Y-axis.
So that's a 200? That looks like a 2,000.
It's a 200. That looks like a 2,000? Really?
Well,
I'd have to have 3
mine
zeros. I don't think so.
Mine looks like a 2,000.
Okay, well, it's a 200, okay? Thanks for, saying I had sloppy writing. Yeah, it's okay. And when you're done numbering up the Y-axis, you should enter 600. It's going up by 50s, but in reality, we're just numbering every other grid line. Okay? So now we're ready to plot our points. So we're going to go to 1, 250. Now, be really careful because we don't have a grid line that represents 1 day. So we have to go halfway between 0 and 2. So we're going to go halfway between 0 and 2, and then we're going to go up to 550, and we're going to put a point there. I wanted that to be red so it would show up better for you guys. So 1 is not on a grid line, it's halfway between 0 and 2, and then it's going to be in the middle between, and it's on 550. So there's our first point. Now we're going to go over here and say, okay, our next point would be at 6, 285. So we're going to go to 6 on the x-axis and 285. Oh, well, that's not a grid line. 250, the next grid line's 275. So I can't go quite halfways between 275 and 300, but just under halfways. And what we're going to do is we're going to make line segments on this graph. So I'm going to give you a ruler, and I want you to connect those 2 points. The 2 that we just put on the graph. So connect the 2 points. No arrows needed. They're going to just be line segments. I don't know, one of them being better than the other. So connect those 2 points. When we're doing rate of change, it's not going to be a nice straight line. Instead, what it's going to be a group of line segments. Okay? And then now we're gonna graph ordered pair. See, I guess I need to get rid of my line tool. We're going to graph ordered pair 16 to 10. So we'll go over to 16 and up to 210. 210 is going to be, it's 200. The next grid line is 225. So again, not quite halfway up, but just under halfway. Connect that point to the most recent point. And then we're ready to graph our next point, which is ordered pair 22, 210. So we'll go to 22, which is a grid line, and up to 210. Well, we should be straight across from our last point, shouldn't we? And now we will connect those two. Should be a horizontal line segment, because they both have the same y value. And then we have one more point to graph, which is ordered pair 30, 175. That one should be on two grid lines that are crossing. 30, 175, right there. And again, connect that to the last point. And there's our little, there's our graph. Dakota? Okay, so we have line segments. Here's what, and so every line segment represents a rate of change. So how many rates of change do we have, do you think? Every line segment represents a rate of change. How many line segments do we have, Trey? 4. We have 4 of them. So we are going to find right now 4 different line segments, and or rates of change, I mean. So right now, when you just put little arrows like this that show, here's where we're actually finding the rates of change for, okay? We're going to figure out how much is it changing over intervals of time. So our first interval of time is from day 1 to day 6. And that's the steepest one, isn't it? The one that's falling the fastest. And then our next line segment is over the interval of day 6 to day 16. And then our next interval goes from day 16 to day 22. And our last interval goes from day 22 to day 30. Okay? So put those rulers down. You're done drawing your line segments. Now we're going to do some arithmetic. Okay, we're going to answer this question last, so go ahead and just leave that alone right now. Oh, actually, we can look at the graph and say, what do we think? The balance decreased at the greatest rate from day what to day what? Rose? Yeah, day 1 to day 6 it's kind of looking like right now. So we're going to, just looking at the graph, that's what we predict. Now we're going to we're going to figure it out mathematically also. So from day 1 to day 6, here's how you have to show your work for these, okay? What you do is, remember, we have the y's upstairs and we have the x's downstairs in rate of change. And we have to find the change in them. How much did it change by? So we're going to do a subtraction problem. If I have $10 and I give $7 away, something's changed, right? I'm going to have to do a subtraction problem, say 10 take away 7. The amount of money I have has changed to how much? $3, yeah. 10 take away 7, I now have $3. Okay, so what we're going to do is, remember, we have to work with the y's upstairs. So we're going to, over the first interval of time, let's start with 550, subtract 285, start with day 1, subtract day 6. Stay in the same order. So we're working with this we're talking about that interval of time right now. The 550, take away the 285. Day 1, take away day 6. We have to keep them in the same order. Okay, what is 550 take away 285, JC? 265. 265, okay. And what's 1 take away 6?
-5.
-5. Okay, let's divide that out. What's a positive divided by a negative, class?
Negative.
Negative. How many times does 5 go into 265? Stefan?
-53.
-53, okay, so we end up with -53. Okay, now, rates of change always have labels. What was upstairs?
Why?
Why, so what was the label be for this? Dollars per day, yeah, we just figured out that it was a -$53 per day. That's the average that it went down. So a lot of money was getting taken out of that account and not as much going in, okay? So, and it looks like, that kind of looks like a good answer because it was going down pretty fast, wasn't it? Okay, so a -$53 per day is the rate of change for the first time interval. Now, again, that doesn't mean exactly every day $53 got taken out. Maybe one day, from the first day, they took out $70. And maybe the next day they only took out $35. And then maybe the next day they took out $60. And then the next day they took out, $48. When it's averaged together over that time period, from day 1 to day 6, we're saying it's a -$53 a day. Okay, now let's do day 6 to day 16. So now we're kind of overlapping. We're using that same one again. So from day 6 to day 16, we're doing that block, the green one. Now, you're going to be tempted to do the 6 take away 16 upstairs in your ratio because it's in the top of the table. But remember, the y's are upstairs. So we're going to do 285 take away 210. And then 6 take away, what was the next day? 16. Okay. So 285 take away 210. Con, what is that? 75. Mia, what is 6 take away 16? -10. What is 75 divided by -10? Isaac, well, I call on you though. Raising your hand doesn't count unless you wait for it to get called on, okay? Isaac.
-7.5.
Okay, and we're talking, remember the label is what again? Dollars, so why did I put a 0 there? Because we talk about it as 50 cents, don't we? 0.5, we don't say $7.5, we say $7.50. So -$7.50 per day. So the rate of change wasn't nearly as much. The account wasn't going down near as fast, was it? Okay, day 16 to day 22. Well, on day 16, there was $210 in the account. How much money was there on the account on day 22? $210. And day 16, take away day 22. 210, take away 210, class?
0.
Class?
0.
16, take away 22. How many days went by? But we have to make it negative. -6. What's 0 divided by anything?
0.
Except itself? 0, yeah. So we have $0 per day. In other words, what? No change, right? It didn't. And notice on the graph, there's no change. It's horizontal, isn't it? Balance did not go down or up. Okay, and our very last one. Our very last rate of change over that last interval. We have $210 to start with on day 22. And how much money is there on day 30? Was that the 175?
175.
Yeah, that's what I thought. And day 30. So notice how these are kind of lining up like they're on the table, but just flipped over. So 210 take away 175. JC, what is that?
35.
35, thanks. Dakota, what's 22 take away 30? Ian, what's 22 take away 30? Okay, just 8? Negative 8. Be really careful about negatives when it should be. Okay, and what's this one divide out to? Negative 4.375. And you know what? We're going to leave it like that. I know it's money, but it's okay. It's okay. We'll just leave it as 0.375. It's like 37.5 cents is what that means. But that's okay. And then per day.
Now, if it is money, can you just round that to negative 4.38?
Yeah, you could. It could also be negative $4.38. I would not count that wrong. Okay, do we still agree that we think the greatest decrease at the rate of change was from day 1 to day 6? Looking at all of our rates of change. Which one is the greatest amount of distance? What's the greatest amount of money being influenced in the account? Rose? Yeah, day 1 to day 6 still holds the prize, doesn't it? It's going down $53 a day in that time interval, and the others it's not going down near as much. In fact, there's one interval where there's no change at all. Okay, let's go to the back then and see what we have back here. We're going to practice one more, because these are can be tricky. Okay, the table shows the average temperature in degrees Fahrenheit, what we're used to, for 5 months in a certain city. We don't know what city this is. Find the rate of change in temperature for each time period, and then during which time period did the temperature increase at the greatest rate. Well, I've so nicely already set up the coordinate plane for us. I already decided what's going to be x and what's going to be y. So what's going to be x? Months. And what's going to be y? Temperature, yeah. And does it make more sense to say so many degrees per month, or does it make more sense to say so many months per degree? Degrees per month makes more sense, right? Okay. So let's finish numbering first of all so we can graph. The x-axis is going by what? Ones. So finish numbering that. I'm going to start skipping some of them because I can't get that many on there. When you're done numbering the x-axis, it should end at 12. I scrunched up the y-axis. In other words, I don't start it at 0. Where did I start it at? 50. What's it going by? 2's. The y-axis has a scale of 2. So again, I'm just numbering every other grid line. So if you're skipping every other grid line like I did, it's really going up by 4s in your numbering. And the second to the last grid line going to the top should end up being 78, which would mean the top one would actually be an 80, wouldn't it? Okay, we have 4 ordered pairs here, 5 ordered pairs, excuse me, 5 points to graph again. This is like a scatter plot kind of, you know, like when we graph scatter plots. So ordered pair 256. That should be right on some grid lines. Ordered pair 356. And what do we do with those 2 points? Make a line segment and connect them. Okay, and then we're going to go to graphing our next one, which is ordered pair 563. That one's not going to be on an intersection of grid lines, so we're going to have to make a good call here. 562, 63 should be halfway between 62 and 64. And again, we will connect that point to the last one that was just graphed before that. Go ahead and finish this up. Okay, this one's a little trickier to be able to tell from the graph which time interval the temperature increases at the greatest rate from. Because there's a couple of them that look almost exactly the same, don't they? So from month 3 to month 5, or is it from month 5 to month 7? It's kind of hard to tell, isn't it? So we're gonna hold off on this one, and we're gonna say, you know what? Let's figure them out the arithmetic way, and then we're gonna be able to compare them and find out for sure. So from rates of change from month 2 to month 3. Okay, what was the temperature in month 2? 56 degrees. Oops, I guess I need to get rid of my line tool again. So 56 take away 56. Oh, that's what it wasn't. And now month 2 take away month 3. So we end up with a 0 upstairs and a -1 downstairs, which is what?
0.
0. Okay, remember what's on the y-axis? What's our label on the y-axis?
Temperature.
Degrees Fahrenheit per month. Yeah, for 1 month. And we divide it out. Everything becomes per 1 on downstairs. So 0 degrees Fahrenheit per month was the rate of change in that time interval. Now we'll go in month 3, the temperature was 56 degrees. What was it in month 5?
63.
Okay. $56, take away 63. -7, right? 3 take away 5,
-2.
-2. A negative divided by a negative is a positive, and 7 divided by 2 is 3.5, and those are degrees Fahrenheit per month. Okay, now let's move on to starting at month 5, when it was 63 degrees. Take away the temperature in month 7, which was 71, and 5 take away 7 downstairs. 63 take away 71. -8. 5 take away 7. -2. -8 divided by -2.
+4.
4, and those are degrees Fahrenheit, and that's per month. And then our last rate of change for our last line segment. We start with a 71 degree temperature in month 7, and month 8 it is 72. 7 take away 8 downstairs. 71 take away 72. -1. 7 take away 8. -1. -1 divided by itself. 1. Anything divided by itself is 1. Except 0 can't be divided by itself. And that's 1 degree Fahrenheit per month. Okay, now we can look at this and say, where was the greatest rate of change? From which month to which month? From month 5 to 7. 4 is greater than 3.5, isn't it? So we're going to go back up here and answer. That is from month 5 to month 7. Okay, good thing you only have 4 problems to do, huh? For homework. Anybody got any concerns about this before we start? Okay.